both Sean, our intern, and myself, we've looked to try and figure out what could be causing the problem. And the only thing that we seem to be able to find at the moment is if you log out and log back in again, sometimes the chat miraculously appears. It seems that's the solution that people have offered a number of times. So it seems to be a known problem with Teams. I'm not sure exactly what causes it, but they suggest that you leave and then come back in, and then somehow the chat then appears. So if you want to try that, then go ahead and then let us know if that works for you or not. So what we would like to do here is bring in Dr. Goutam Sarker and then all of the CRTLE staff and fellows, just for sort of an informal Q&A based on the GTA experience. So Dr. Sarker is the most recent graduate among us. He just graduated over the summer with his PhD in biology. But as I mentioned, for a number of years has worked with the CRTLE with an I, the UTA, as well as our CRTLE, and is very, very passionate about teaching and learning, and so has a real good handle on what graduate students, particularly at UTA, are going through and what opportunities there are for them and for you. And so, Goutam, I'd like to bring you in, and again, feel free to ask questions. Feel free to leave and come back in again if you want to see if the chat shows up, and you can put your questions in the chat as well. Goutam.
Thank you so much, Dr. Clark. It's an opportunity and honor to be here and talk to the new PhD students. So thank you, Dr. Clark, again for the introduction. I'd like to share a little bit of background. So I completed my bachelor's and master's from Jahangirnagar University in Bangladesh in biology. Then I taught for 7 years in a school, 11th and 12th graders, biology lecture and lab courses. Then I moved to UTA, and I have taught several lab classes as instructor. Please feel free to ask me any questions that you have in your mind.
So Goutam is as a first-time GTA, and particularly one coming from another country as well. What was some of the experiences that you had? Maybe some of the surprises that you encountered, and how did you overcome them?
So when I moved in over here at UTA from my country, the classroom settings, the classes I was teaching, and also the lab I was taking, and also the lab classes that I was teaching, I found they are completely different than the classes back in my country in terms of engagement. So in my country, I found that like most of the classrooms, there is no engagement at all. So teachers usually don't you ask any questions and don't you give that opportunity to think and speak out of your mind what you learned, what you think about one particular problem. It was kind of, delivering lecture, and it was like one direction. But over here, I found it's much more engaged. Students and instructors or faculty member, they are very engaged in conversation. And that's what I tried to do from my second semester of teaching. The first semester, I'd say I learned, I observed, and from the second semester at UTA, I started implementing those. And I was very fortunate to involve with CRTLE, with both CRTLE, and through involvement of my with CRTLE, I learned a lot of techniques that I can implement in the classroom, in the lab, to engage with the teachers and also with the students. I'd recommend all the new students, new PhD students, to take this advantage. It's not about teaching, it's about engagement. So this is applicable outside of your classroom too.
So what's talk about some of the techniques you use to engage your students in your labs in particular. Some of the things that you've tried that maybe worked or even didn't work.
So one technique I implemented in like third or fourth semester in the lab class. So lab classes are different here from the lecture classes. Lecture classes are very big in terms of class size, 100 or even 200 of students in one class. But in lab classes that I taught the class size is 24. So it was very easy for me to implement some of the techniques that I learned. One of the techniques I implemented for engagement is index card implementation. So why I did that? First of all, in the lab classes that I taught, there's 10 to 15 minutes window at the beginning of the lab that I actually deliver a micro lecture on the topic that we will be doing in the lab class. So in that micro lecture, I asked my students in the lab several questions to get that engagement, to see how my students respond. But I found like that didn't work well. Many students don't show their hands, don't raise their hands. Few of them actually respond to my questions if they have got the topic or not, if they have any question or not. So what I did in one particular lab that was kind of math based. If you know biology, that there is one thing that is called Hardy-Weinberg law. So in that lab, from my previous semester's experience, I found that I have a very little engagement in that particular lab. So what I did give them 3 sticky notes, 3 colors. They have 3 colors: green, red, and yellow. At the beginning of the lab, I told them, if you know, or if you are confident in understanding and also explaining the Hardy-Weinberg law that you have gone through in your lecture class. And I also recommended them to go through the lab activities first. So they have gone through the lecture and they have also gone through their own reading of the lab activities. So I told them in the beginning of the lab that show me the green label if you have understood and if you are confident that you can explain the Hardy-Weinberg law. Show me the red card. If you are not confident, but if you get the concept, but you are not confident enough to explain, show me the yellow card. And if you don't have any clue, just show me the red card. So what I found is that very few green cards, and most of them I can still remember, like there are only 2 green cards out of 24. And there are several 8 to 10 yellow cards, and most of them are red cards. So I explained the law in my mini lecture for few minutes. Then I asked them, now show me your cards if you get that concept. And I surprisingly found most of them are showing me the green card. And that was expected, and that I wanted to actually to do to know if my students get that concept or not. And also at the very end of my micro lecture, when I wrapped up what we will be going through in our lab and what this particular concept that we will be testing in the lab. Again, for the final round, I asked them, show me your cards. I found only 2 yellow cards at the very end. So that was a good indicator for me that you can engage with the students, and also you can actually measure if students are learning the concepts or if they're getting the concepts or not.
That's good. And there's other tools you can use too, similar tools, the polls, like the poll everywhere, which I used in course, and there's Kahoot, and there's others where you can ask the questions, and but it's good to be able to get that feedback from the students instead of just assuming that everybody's on the same page or everybody knows. Really asking for individual feedback from the students, and being willing to look for ways, or maybe even getting fellow students to work with each other. Those that say they understand it, then work with those who may not understand it. Right?
Yes, yes. That I also tried that, and that worked very well. And Dr. Clark, as you mentioned, this is called like a think, pair, share. You need to think yourself, then you need to share with your peer. Then you're going to share with the whole class. That's another great technique for the student engagement.
Can you just elaborate a little bit more on the think, pair, share?
Yes, it's a technique. So you can ask your students. You can give a problem to your students, right? Every student's gonna think on that problem about the solution, how they're gonna approach to solve that particular problem. And after like 5 minutes or so, or 2 minutes, or whatever you whatever time you actually allocate them for thinking, then I ask them, 2 students who are sitting side by side, to share what they have came up with the solution. So they are sharing their solution to each other, and to see if their both of their solutions are similar or they have differences, if they have discordance. They're gonna sort that out, and then they're gonna choose which one is better, or which one is more acceptable. And we had like 4 students in a group. So after they have sorted out within the pair, they're gonna sort to another pair. They're gonna share that idea with another pair. So each table has one final thought, one final solution, and we have 24 students and 4 tables. So we had like 6 final solutions. And at the very end, they're gonna share from each of the table. They're gonna share what their solution is to the whole class. So that is kind of think, pair, share. 2 students gonna pair, think individually, then they're gonna share their thoughts, then they're gonna share with their groups or classrooms. You can make some sort of adjustment over there. Depending on the classroom size and the mode of teaching and the topic you are teaching.
That's good. Questions? Any questions for Goutam so far? Comments? Any questions on being a grad student and approaching teaching? Yes, no? I mean, Goutam and I can continue on chatting. Mr. Ott, yes.
Dr. Sarker, did you have to take any classes before you started as a teaching assistant?
So for the first semester, I was teaching. I was co-teaching a lab, but for special like training, how to teach a class, I didn't go through any formal training. But as I said, like from the very first semester, I was involved with CRTLE, CRTLE, then CRTLE, with both of the CRTLEs, and they offer a lot of resources, and particularly CRTLE that offers many online courses each semester, how you can improve your teaching. And I took several courses from there, and those are not like credit courses. They are like kind of online resources and courses that definitely improve my understanding and also my techniques to improve my teaching in the class.
Thank you.
You're welcome.
And you, I mean, as part of the CRTLE, they have a lot of different workshops, and it's a nationwide consortium, right? So it's not
Yes.
just, yeah. So it's kind of, but you work in small groups with some fellow grad students at your institution, but then you also, take part in these national things, correct?
Mm-hmm. That's correct. That's correct. So since this situation is different with the pandemic right now, every semester CRTLE offered learning group activities where like several PhD students or graduate students come together and they share their ideas about teaching to each other, and that helped me a lot too. And if you have given a chance, or if you got a chance to interact with graduate students, they are your peers. So if you have got a chance to share your ideas, to discuss, I'd highly recommend you to do that if you have time.
So as you've worked with graduate students and you've been one yourself over the last few years too, what are some of the most common problems that you see that graduate students face when they're asked to all of a sudden enter the classroom or take charge of a lab or something like that? What are some common problems that students have faced?
So one common problem I'd say for graduate student is the assumption. What does I mean? So assumption means that when I teach a class, I might assume, well, this topic is very easy for the students. That might not be true, because that topic could be very easy for you, but not for the students. There are many students who came from underprivileged background. They are like intellectual merit. They have their intellectual merit, but they didn't come from a very good school or school district. So that's why the topic that you are thinking, it should be very easy for the students. Actually, that is not true for many students. So you have to figure that out, and you have to help your students in that. So don't assume, try to see if your assumption actually holds true or not. And also, if you're assigned to a new class that you actually didn't teach, I'd see that is an opportunity to grow and to learn from your part. I'd recommend you to take that opportunity to teach. Don't shy away from any course that you didn't teach before, and you're thinking, well, if I teach a new course, it will hamper my research research productivity, or I just want to teach one class, like one particular lab class for whole of my graduate student life, so that I don't need to prepare. I don't need to do extra work. I think that's I don't recommend that. I'd say just take it as an opportunity to learn and to grow.
I think it's some really good advice. I mean, it's really good advice. It's temptation not only for graduate students but for faculty to be comfortable in a particular class and say, well, that's what I'm going to teach. I know it, and I don't have to worry about a lot of course prep. But life's about learning and growing, and as a graduate student, if you're asked to teach a class or assist in the lab or whatever, I mean, that's a privilege and it's an honor, and work and see it as an opportunity to grow and to learn. You don't have to always be the world's expert on a topic to be able to teach that particular class. There's a book that I read a couple of years ago called Teaching What You Don't Know. And the professor was basically, the premise of the book is basically, we're all asked to maybe take on a class that we don't know a lot about, that may be a little bit outside of our area of expertise. But by doing research and by teaching it and by learning it, then we start to become comfortable and we start to become an expert, and we're able to teach. It's being able to put into practice those principles that we've already heard and talked about this morning, correct, Goutam?
That's completely correct. I completely agree with you, Dr. Clark.
So have you had that opportunity to teach what you don't know?
Yes. I taught like several classes for the very first semester. When I started over here, I was assigned one senior level class, comparative vertebrate anatomy, and I was like co-instructor, but I took that opportunity. And from after that very first semester, I taught like several courses that is not related to my research, and that is definitely not related to my background. And I actually, like in one instance, I actually asked my lab coordinator to assign me a different class.
and did they?
Yes, they did. Yeah, there's very generous about that.
So something you said a little earlier was about thinking about how the student and where they are in teaching. That was surprising, and I found that too. And I started studying learning progressions. It's in the literature in education. I tell Dr. Clark, we have names for everything in education. You want to know what something is? We have a name for it. The type of question you ask, the type of whatever it is you want to know.
I didn't know what I don't know.
And anyway, so learning progressions is, what do they need as their foundation? Okay, if they don't have it, then you've got to help establish that foundation knowledge, because they can't learn from that. And I'll talk about that a little more in my session. And then but you have to go to where they are and what they know, and then build from there. So like you said, Goutam, you don't just assume that, okay, they should all be here. Well, they're not. You're going to have a variety. And so you have to think about, how can I establish that foundation and then grow the knowledge from there, and you'll get a lot more success, and you'll find a lot less frustration in the students and that kind of thing, and you're helping them through. So I wondered about that, as far as how you went about figuring out what they know. I mean, do you give a pretest, or do you do anything to try and figure out what they already know?
So thank you, Dr. Clark, for this question. This is a great question. Mm-hmm. So my motivation, or don't assume, like this particular principle came to me from one particular instance. That is in one particular lab, when I was talking with my lab coordinator and other fellow instructors, I found one instructor was saying, well, this lab is very easy. It should go like a breeze. You don't need to do anything. You just sit there and the student will do their activities and the lab is over. And they love it. That was the comment. But based on my experience, I actually didn't accept that statement, or didn't agree with that statement. And I wanted to quantify that, or wanted to test that if that is true. So what I did at the very end of the semester, I did survey. I sent a survey to my students, like about 48 students, 2 sections. And I also surveyed all of the instructors who are teaching that particular lab, 1442. And previous instructors who already have taught that particular lab. So I asked the students, which particular lab do you think is very easy and you understand a lot? And which particular lab you feel like very hard and you feel like you don't like it? So 2 questions, just 2 questions. I asked the same question to my instructors, saying that as an instructor, which particular do you think student likes more and they think these labs are very easy? Or which labs are very difficult and you don't like it? So when I compiled the data from my instructor's data, it was about 12 instructors, and students was about 48 students. So when I compiled the data, I found a huge discrepancy. And in most of the cases, all the instructors who assume this lab should be the most popular and most easy one for the students. That's wrong. There's no a correlation between the assumption of the students and actually about the students and about with the students feeling or students learning what they are actually learning. So that was the motivation of doing that kind of survey. And for my following semesters, what I did to learn what particular topic they actually struggle most. At the beginning of the micro lecture, I gave them a particular list. Dr. Fleener and also Dr. Clark and Dr. Cavallo, you already have mentioned that. Give the objectives or learning goals for each of the classes. So I give them learning goals. Then I introduced all of the topics that which are main and which are essential for them to understand the lab, to succeed in the lab. And I asked them which particular topic you feel very hard or very difficult for you to understand. So I figured that out. Then I explained them. I figured that like I don't need to spoon feed them for each of the topics, but the topics where they need actual help, I teach that apart and then I explain them. And also, Dr. Cavallo, you mentioned a little bit that did I do any survey? For one lab, I did a survey like at the very beginning of the semester, like at the very first day. What are their learning goals? How confident they are, and what particular topics they think would be very difficult for them to learn. So after sorting those out, I redesigned or kind of not redesigned. I prepared my mini lecture according to that, or keeping that in mind, which particular topic is very difficult for the students.
That's great. It's great. You get their viewpoint and their confidence, and you know who you need to support a little more. And then having if you have questions on all the topics, you can also see as a whole, say you're teaching biology, where do they have the most difficulty? Is it with genetics? Is it with, cell physiology? Where do I need to really give them that much more foundation and if you do that, just a pre-test, what you want them to do, you might count it for some kind of small point just to complete it, because you want them to actually interact with the content and treat it like not as a throwaway, but like they really are putting their effort into answering the questions. So those are all good, and just to get to know a little bit about the students that are in your class and where they are. Love it. Very good. Any other questions or comments from the group? We still have a few more minutes for conversation. I don't know if the chat has been working.
Dilson, yeah,
this one. Go ahead. Make sure you unmute. That's common for me to forget.
Dilson, can you hear us?
Yes, I hear you.
You hear Dilson?
I see Dilson.
Yeah.
You have raised your hand, so please ask me the question. And please unmute yourself first.
No.
So yeah, so you have to unmute yourself if you want to ask a question. I'm not sure if you raised your hand to ask a question or not. Sasha?
Dilson Sasa.
Dilson Sasha?
Mm-hmm. Okay. Also could be technical difficulties. I know I'm having good connection today, but sometimes it doesn't work so well. So you never know.
Well, we got 5 more minutes left. So, any other questions or comments for Goutam? I mean, it's been great. You've really had some great advice and some good thoughts for graduate students.
Thank you so much, Dr. Clark.
Mm-hmm. So feel good to be done with your PhD?
Yes. Finally, it's done, and I feel very confident, and I feel like I'm a critical thinker now, certified.
There you go. Yeah.
That may be one question to bring up, and I think it's probably a common question too. But the balancing act of studying with teaching, with writing a dissertation, with, I know in your case, caring for, having a family and a young child as well. Can you talk about the balancing act?
So it was very difficult for me actually to balance, but it eventually worked out, and my family, I really thank them. They were very helpful to support me. I tend to be at school early in the morning so that I can actually focus on my own work, and I definitely did put extra effort because I wanted to overcome my disadvantages that I had. So one thing I'd say that I had, I'd say like cultural thing, and I wanted to interact more with my fellow lab mates and graduate students and with everybody. So I attended a lot of meeting or like campus activities to overcome with that, to gain more confident. But to do so, I had to sacrifice many fun things like there's like one invitation one day or one night that I couldn't attend. So there's something that I had to to put more effort on my research and teachings. But eventually it worked out really well. Through my involvement with both of the CRTLEs, I learned a lot of techniques that actually was translated or was applicable to my own research. So I found a bridge between these two activities so that I can actually be productive in both of my activities, my own research, and also as a graduate research assistant for my for CRTLE. It was definitely not easy, but it was manageable, and I did that. You have to push hard yourself. And I learned that at the very first semester or second semester, I'd say, when my advisor, he gave me a good advice that in graduate student, you are adult and you are self-motivated. Nobody gonna motivate you. And you have to take that responsibility, and you have to take that sort of stake to go further. And that was my motivation, that I have to motivate myself and I have to take care of everything.
That's fantastic advice, definitely. And do things one day at a time. As a doctoral student, my advisor would say, when I was stuck on my dissertation, I'm like, he said, just give me a page, give me something, because I can't help you with a blank page, but I can help you with just anything. So I started, and then pretty soon one page went into two, when it finally started getting. He would give me feedback, but you got to start that ball rolling and definitely have to self-motivate. So because I mean, you can't stay in this stuck position forever. You gotta move, and you gotta put something. You gotta trust yourself and trust your knowledge and go forward one step at a time. And before you know it, 300 pages later, we have a dissertation, right? Or however many pages it happens to be.
It was more than 200.
Yes. Right.
Wow.
So, yeah.
Well,
So,
good. Goutam, thank you very much. We really appreciate it.
Thank you.
Great advice and great insight. And again, Goutam's available too if you've got questions or comments and want to reach out to him. I just want to reiterate again, I know that we've been having trouble with the chat, and the best advice that I've been able to find online, and Sean, our intern, has found the same, is just to log off and log on again. I don't know if that's going to work or not. I can't guarantee it, but it seems like this is a known issue that sometimes the chat disappears for whatever reason, and people have said just going out and getting back in again makes it available. So if you're able to do that and the chat does appear, then let us know just so that we know that it's up and running. Otherwise, without the chat, please feel free to raise your hand. Feel free to offer questions or insight, because we do want this to be as interactive as possible. So if we look at the schedule then, we have scheduled just a couple of minutes break here, and just to stretch your legs and to maybe get a drink or something, whatever you need to do. And then Dr. Cavallo is going to come back and talk about advancing student thinking and meaningful learning. Well, I mean, I guess you were scheduled to start now, weren't you? So, I mean, we've kind of gone over just a little bit. So
I guess we actually went over. Yeah, I would look back at the schedule because we were ahead the whole time. And now we're still good. We're all good. So I
mean, if you want to start now, feel free. I kind of lost track of time actually. I was so engrossed in what Goutam was saying. Goutam, you just, that was great.
Yeah, it's very good. That's fine. I could.
Thank you so much, Dr. Clark and Dr. Cavallo.
Thank you. I can go ahead then.
Yeah.
I'll go ahead. Okay, so I'm going to share. I need to share my screen though. I need to get the right presentation up. Not this one. The other right presentation. This one. Start from the beginning. Slide. Beginning. Okay. Okay, so welcome everyone. If you're just joining us, we're again glad you're here. I know some had obligations in the morning, maybe just joining us now. So we are happy that you've joined if you've been able to log on. My topic is advancing student thinking and meaningful learning, and by doing that, you promote engagement in learning. And so I'm going to go through my presentation. Oh, I hear a dog.
Sorry, that's mine. I'll mute.
I'm going to start. Yeah, that's all good. You know, pets are allowed. Pets are welcome. So I'm going to start with what's called a private universe. I need to unshare. I'm figuring this out, so bear with me while I unshare and then try to get the video on real quickly, because that's the process.
Don't forget to check the little box too.
I gotta check the box. Yeah, thank you. And I'm trying to remember to check it. Got it. Got it back. And now I need to go to the private universe video. I don't know if I did it right. Hang on. Oh my goodness. We'll get it. Include video. And then I want, let me know if this works or not. Do we have it? Do you have audio?
We have audio, but not video.
Okay. You know what? All good things. They work when you practice, but
just follow Dr. Fleener's lead. Technology is our friend.
I can try. See, it doesn't work. I had it. I really did, but it's okay if I can't get it. Unshare.
We saw the video and then you maximized our pictures. So.
Oh, okay. So I maximized the wrong thing. But you saw the video for a second?
Well, it's screen.
You saw the screen? It's not showing up. Okay, hang on. You see all yourselves now, right?
Yes. Yes.
Okay, we're gonna undo that. Oh my goodness. Okay. So that's a good thing we built in extra time all the time. All right. It's going to be. All right, maybe then. Okay. Okay. Well, we are gonna we're gonna go on to the next thing if I can't get it to go. So, and then one more try. Okay. And then we'll go on to the next thing. And if it's not gonna work, put it on first. This one. And then, so I'm working off one screen, so it's very different to do that. All right, well, if this doesn't work, we're done.
There you go.
Is it here? Okay, whew. Okay. Thank you for bearing with us. Can you hear it?
Yes.
Okay. Very good.
I'm not hearing anything now. No, we're not hearing anything, Ann.
Ann, I think you muted yourself. That's the
Yeah,
reason we can't hear anything.
we're not hearing or seeing anything, Ann. Are you still there? There you go.
Yeah, I'm still trying to mess with it. Okay, now I need to see if I can play it one more time. This is like anything.
There we go. Yes.
Despite a
Hear it?
lifetime of the very
It's
best
perfect.
education, students in our classrooms are failing to learn science. Many of these students will graduate from college with the same scientific misconceptions that they had on entering grade school. To test how a lifetime of education affects our understanding of science, we asked these recent graduates some simple questions in astronomy. Consider, for example, that the causes of the seasons is a topic taught in every standard curriculum.
Okay, I think the seasons happens because as the Earth travels around the sun, it gets nearer to the sun, which produces warmer weather, and gets farther away, which produces colder weather, and hence the seasons.
How hot it is or how cold it is at any given time of the year has to do with the closeness of the Earth to the sun during the seasonal periods.
The Earth goes around the sun, and it gets hotter when we get closer to the sun, and it gets colder when we get further away from the sun.
These graduates, like many of us, think of the Earth's orbit as a highly exaggerated ellipse. Even though the Earth's orbit is very nearly circular, with distance producing virtually no effect on the seasons, we carry with us the strong, incorrect belief that changing distance is responsible for the seasons.
I took physics, planetary motion, and relativity, and electromagnetism and waves.
I've never really had a scientific background whatsoever, and I got through school without having it. I've gotten very far without having it.
I had quite a bit of science in high school, yeah, through physics, first year, and 2 years of chemistry.
Regardless of their science education, 21 of the 23 randomly selected students, faculty, and alumni of Harvard University revealed misconceptions when asked to explain either the seasons or the phases of the moon.
When it's further away from the sun, then it gets colder.
The Earth's position interferes with the reflection of the sun against the moon.
Okay, that's we can end there. So so the idea here that I'm presenting, I'll go back to sharing my slides now. I would really love to hear in the chat, but since we can't use the chat, we'll figure out another way if you'll just hang on. I got to get this off. If we can just think about why there's so many struggles with this type of concept about the Earth and the moon. Now it's just, I mean, the Earth and seasons. Now it's something really basic in science as far as what makes the summer and winter different, and where the sun is, and it's really the tilt of the Earth, as you know. So what does it mean for our students? What they've gone all through school taking science, but they're still struggling with something basic like what makes summer warmer and winter colder. And so a lot of that has to do with how they've learned and what has happened to the concepts that they've been learning as they're going through school. What is it that they're gaining, and where are they struggling? And so part of what we need to do is think about how we teach, because a lot of what they gather is just from common sense and common experiences of the world and how it works in any field. It's not just science, but any field. And so we have to think about what our communication to them is when we're teaching them, and how it's processed in their minds to come up with understanding. So that was, there's a whole series, if you ever want to look at them, the Private Universe, and it has a lot of these kinds of videos and helps you really think about how people think. So next I have this activity that I would like you to do. Now the problem is I'm still not getting chat really, but I could ask you to then call it out. But there's an activity I do, and it's to help. It's an activity that helps you think about how you might think when you learn. And if you already know this, you can't give it away. You're not allowed. But if you don't, if you do already know it, you can just play along. If you don't, then you're to process this information. So this is an activity called Fannie Dooley, and she likes some things and does not like other things. And your job is to figure out what she likes and doesn't like. So I'm going to say some pairs of words of what Fannie Dooley likes and what she doesn't like. You need to determine what you think she likes and doesn't like and why, and then just give an example. But don't tell what the rule is of how you know what she likes and what she doesn't like. Just give an example to everyone. Okay, got that? Because we want examples only, don't give the rule away. So if you can't do the chat, since I've not found it to work, raise your hand and give an example. And it's okay if you make a mistake, right? This is a safe place. You can don't have to be 100% correct. But I will say some of the things. So here's what Fannie Dooley likes, and here's what she doesn't like. She likes sunny days, but not sunshine. She likes to giggle, but not to laugh. She likes jelly, not jam. She likes trees, not plants. She likes deer, but not elk. Can anyone give an example? Who can give an example? Don't make me call on you. Give an example of something she likes and doesn't like.
Kelly had her hand up. Kelly.
Kelly.
Yeah, I think she likes puppies, but not dogs.
Exactly. She likes puppies, but not dogs. Have you played this before, Kelly?
No, ma'am.
Oh, wow. So, okay. Then I can give a few more examples and you can keep giving them, Kelly, or anyone else who wants to give it a shot. She likes sparrows, but not birds. She likes butter, but not bread. She likes the colors yellow and green, but not red and blue. Who has an example?
Thomas says she likes summer, but not June.
Yes, she does. She doesn't like July or August either.
I'll add that she likes buttons.
She likes buttons. She does. She does like buttons. She likes streets, but not roads. She likes dollars, but not money. And she likes beer, but not wine. Thought I had to throw that in. Any other examples? Who else?
What if she likes basketball but not sports?
Yes, she likes basketball, not sports. But she doesn't like hockey or rugby.
Ooh.
But she does like baseball, volleyball. She likes those. What else? Any other? Go ahead and throw something out there.
Tom says she likes school but not learning.
Correct. She likes school but not learning. Exactly. So what you should be doing now is trying to process information. Okay, get a couple more. I'll move on to the next one. Next slide you can see, because I wrote some of them down. So here's some more of them. Jelly, jam, she likes butter, she likes everything in this column. Skiing, not skating. Summer, fall, not winter, spring. Her Mississippi is her favorite state. Raise your hand if you think you've got it. Well, I can't really see both screens at once, but maybe
I'll monitor. Yeah.
How many? Yeah.
So raise your hand if you think you have it.
I'm trying to see if I could see it on my phone.
I know one because I know Kelly had it.
Yeah.
But raise your hand. We got 2, 3. So Karina thinks Kelly. Saravanan. Yeah, there's a few. Daniel, Henry, Sai. They all think they've got it.
Good. We're getting there now. Puppies, not dogs, was mentioned. That's a good one. And this one is a good one. Hopping, but not hoping, because there's only one thing different about hopping and hoping. And you can't think too hard with this, because it's not. Yeah. But think about how you're thinking while you're trying to solve the clue. Grass, but not flowers. I mentioned that. I had to put in, here they are, Yankees. But sorry, not the Mets, Rangers, Red Sox. Cars, Nissan, not Toyota. Running, not walking. But really good ones are, these states she likes, these she does not. And then hopping and hoping. She likes mommy, not mom. That's another one.
Oh, I get it now.
Got it.
Destiny got it.
Hey, can you give an example?
So
without telling you, without telling either way, yeah.
Like, like I said with basketball, I would say I like soccer but not sports. Is that like?
Yes, that works. Yay!
I get it now.
Yay! All right. Anyone else? You got to look at these words. They all have something in common that these words don't have. I'm giving you some what's called scaffolding I'll talk about later, giving you some clues. So, but we can, in a class, I would do this until every single person got it. Because I want them to go through the struggle of what are you doing? I don't understand. And I don't let them off the hook because I want them all to process the information and see. It's just a game, but it's teaching about learning, I teach teachers about learning as well, and to think about how we process the information. So, Destiny, what did you do when you first started hearing information? Like, what's something you did? I mean,
with me, I had when everyone was saying the words, I was listening to it. But then when I started looking at the examples you were seeing, I kept seeing a pattern on the likes.
Oh, good.
So
good.
it made it more easier for me to understand what was going on.
And you absolutely are trying to make a pattern. And that's what we do with any information we get from our environment, is that we try to organize it in our mind and try to find a pattern that we can hang on to that makes sense. And so a lot of people will start thinking, well, because I purposely said jelly and jam, which are kind of related, to see if, that definitely throws people off. But because it's nothing to do with that, right? We haven't said what it is yet, but it has to do with something else. And, doing two sports. But I could have said she likes soccer but not wine, and it would still work. Or she likes, running but not plants, and it still works. So those are things it's to process. So because of time, and I will continue on, but the idea is that we struggle to try to put the words together and make sense out of them. And then I heard that at least Destiny, some of you might have been muted, but when she got it, what did you hear? What did she do? She said what?
Yay!
And that is part of learning, because you're like, I got it. And you feel happy. And that is the most powerful thing you can do in teaching and in learning, is to bring those students to that happy place where they feel good that they figured something out and they got and they figured it out for themselves. Because you could just tell them, but it's not the same impact and the same process of learning that you went through when you go, I get it. So now I'm going to kill it because of time, and because we're virtual, it's a little bit harder to see all your faces, because I look at all of them and I see, do you have it? What do you think? What do you think? But face to face, it's a little easier, but you can still improvise, and that's what we're doing. But if you notice something, Destiny, why don't you give it away? What are all these words have in common?
The stuff that she likes, it has doubles, like the double letters.
All have double letters, so it has nothing to do with anything except that these words have double letters and these words do not have double letters. I know it's dumb, but it's a game to help think about how people think and when they learn something that's new. And so what we do when we learn something new is, first thing we do is we try to assimilate information. So those of you that were involved, we're trying to take in information by listening and making sense of it. Some of you may have tried to write it down to look at the words, but that's why I had the slide that also to help you see it visually as well. But you're trying to take in with your senses as much information as you can about something, whatever that new concept or idea is. And we do this throughout our entire lives, even as babies. We try to figure out what this animal is and what this thing is, and why does this make a sound, when I hit it or kick it. All through our lives, we try to assimilate and find a pattern. You walk into a new grocery store you've never been in before. First thing you do is assimilate. Where's this? Where's that? You're looking around at the signs, trying to organize the store so that you can make sense out of it. And we're using our senses to do that. We might be in disequilibrium. That's a state of a little bit of confusion where we're trying to make sense out of it, but we're stuck. We could be stuck. It's like, what? I don't understand this. So the arrow goes both ways. So we go back and we assimilate more information and try to take more in, and till we try to make sense out of it. And then finally, when you go, oh, I got it, that's accommodation. And that's the aha that we talk about. That's the light bulb you've heard in education that we love to see. And it's when students get something, but it is something that is motivating and makes them happy. To have them assimilate something on their own and go through the process in their mind, if they're doing a hands-on or whatever it is, go through disequilibrium, but you don't abandon them here. You got to help them. And that's why I was giving more clues, and I was, showing how to, what it looks like in print. And I was saying things like hopping and hoping, or, there's only one thing different, trying to give you some clues to bring you along so that you didn't stay stuck in disequilibrium and eventually get the, I got it. Then we take that new knowledge and we have to organize it in our mind, in our mental structures, so that it fits somewhere. Like, we can't just go, oh, that was cool. We have to take that new thing and organize it. So hopefully you're organizing this activity with how people learn in your mind, as and this whole cycle of what we went through playing that simple game, assimilation. We went through assimilation, accommodation, and now organization. By talking more about it, it's helping you to organize. Why did we do this? Where does it fit? Because a lot of students will say, why did I do this? Why did I have to learn this? That's when they get to accommodation, and then, it ends. When you say, no, this fits with how this works in the real world, or that's what organization does for them. There's something real world that connects with it. And something in your previous knowledge that can connect to it, and something you're going to learn next that connects with it. And that helps them organize that structure in their mind so they understand it, and it solidifies it in their mind when they learn that way. So we think about it as a child. If any of you have children or have been around young children, nieces, nephews, you see that they, they're trying to figure things out in the world. And my own children called every animal a dog at first, and then eventually saw that there's differences between dogs, cats, you name it. And eventually they even refine it even more, because there's different kinds of dogs. A Chihuahua and a German Shepherd are still dogs. So how do they know that? There's features about it that are common that we have to assimilate and organize and accommodate and organize in our mind, and they eventually do that. And sometimes when we see something new, we have to try, we're in disequilibrium, we have to try and figure out where it goes in our mental structure and in our mind. So that happens every day to us, with us. Sometimes it's disequilibrium is quick and we immediately figure it out. Sometimes it takes a while. So if you think about them taking a grocery store analogy, and then they decide to remodel, right? And then move everything around. We go back to the store we're so familiar with, that we've already accommodated, already relieved and said, yes, I know where everything is, and organized. Now they go and they change it, and now we are in disequilibrium again. I'm like, why did they move this? I can't find it again. So that what we're trying to do is allow them to feel disequilibrium, but then put them into accommodation and then organize that knowledge so that they are they reach that level of relief, of cognitive relief, and I've got this, I understand now, I can move on and learn something new. And that's we all go through this every day. I think about a car. When you have your own car, you learn where everything is and how it works. Then you get, let's say, a rental car or someone else's car, and all of a sudden you've got to assimilate that car now. A new car, a new place. Where is everything, and how is it different than my car? So it takes a little bit of it's not as difficult because we know how to drive already, but we have to assimilate, go through a little disequilibrium, and then we accommodate, and we then organize that car. Now I know how to, that where everything is in this type of a car, Toyota versus a Dodge or whatever it happens to be. So so the process that we go through in learning is that we assimilate, accommodate, and organize. Disequilibrium is in between. And we're trying to create what's called equilibrium in their mind, where they fit new concepts. When we're doing this in teaching, we're fitting new concepts that we're teaching in with what already exists in their mind, their schemata. And they have to find where to put it so they can organize those thoughts. And this is so now I'm going to have you do this activity. Only you're going to have to, when I do this in class, I have people draw, so you can sketch it out. Unfortunately, you can't really share, but we could talk about what you think is being described. But something here is being described, so I'm going to be quiet and let you read through, and then I'll ask you to call out, raise your hand. Dr. Clark's going to help out, calling on you as to what you think is being described. This is something being described here, so so read it, and I'll be quiet while you read it. Go ahead. Okay, and raise hands if you think you know or can describe some or all of what is going on here. Any takers?
Doesn't matter if you're right or wrong, but just feel free to raise your hand and have a guess.
Just guess.
Daniel.
Yeah, I think it's about either the sound reaching a destination or some communication breakdown. Something is being transmitted but cannot reach.
Okay. Good, good. Something's being transmitted, can't be reached to the person it's going to. What else?
Tilson?
I think it's about how sound travels.
Mm-hmm. How sound travels. Anything else on that? What else?
Dr. Cavallo, I'm thinking it's a long distance phone call.
Okay. Okay. Long distance phone call.
The old fashioned phone calls with the wires on the wall. Not
We're
the
on
cell
wire.
phone.
Right.
Not the cell phone.
No cell phone. Yeah.
Other guesses.
I'll wait a little bit. And again, this is another one I give to students. I have them draw it out and in a group, and then they present what they think is being presented or what is being described.
Henry.
Yeah, I think there is someone in trouble, but he is isolated. So they can't, even if they try to shout, there is a building, there is the property, they are engrossed in a house, but they are in trouble. Yeah.
Good, good. Good one. Okay.
Mr. Wright.
I think it's saying that no matter how information is being carried out, if it's not carried out properly, the other person doesn't assimilate and understand it.
Very good. It's good. Kind of goes along what we're saying. So when I give this to students, if I gave it to individual students, let's say I gave it to individuals and I said, okay, describe or draw what this is or describe it. And I have, let's say I have 30 students in my class. How many different descriptions do you think I received?
A lot, probably.
A lot. Probably about 30. Yeah. And when I usually do it in groups of, let's say 3, and everyone is something different. But what the point is here is that it's the same words. Everyone's reading the same words, but we're processing those words in a different way. And this is what it feels like to students who are trying to listen to a lecture where they don't have the experience of what's going on, or read a textbook that first before they really have any experience with it to understand it. They're trying to put it together, and it sometimes creates a difficulty in assimilating. Someone mentioned that assimilating becomes very difficult when it's just words alone. If you look at a page of a biology textbook, and you read through the paragraph, there are so many words that the students probably, they have to know all the meanings of all those words. Homologous chromosomes and alleles, chromosomes, nucleus, DNA, RNA, traits, and so many different terms. And in one paragraph even that they have to try to make sense out of. And if they don't understand what's being described, they're going to have different responses. The difficulty here is with assimilating. Students have difficulty assimilating straight from text without having, or from straight lecture, without having experience first of what it is. And get ready, because here's what is being described. So this is the description. I think it's, again, a little crazy, but that's what I do. And it is it makes no sense, but if you saw this picture first, then read the text, would it make more sense? Like, yeah, go ahead.
Yes.
Yes. Yeah. So, and that's why we have to give them physical experience of some kind so that they can assimilate. We can assimilate better from different kinds of experience, hands-on experience, or visual pictures and things like that. And then when we go and read the text, and this is for everyone, then we learn better. You may have heard of something called learning styles. That has been discredited in the literature. It is not. There is no learning styles. It could change all the time, and we don't want to classify or categorize students like that and say, well, I didn't learn because I'm this. So the research does not support learning styles. What it does support is that every single person on earth learns best by experience first, having the experience as much as possible. I do an analogy again that I could tell you everything you want to know about Seneca Falls, New York, where I grew up, unless you're from there. If anyone's from there, say hey. I could tell you where the buildings are, where the schools are, where everything is. But how will you ever really understand what that town is like? Hopefully, that's a rhetorical question, but you have to go there, and you have to be there, and you have to see it for yourself. And I've used the car analogy. I can teach my children everything about the car. Here's the gas. Here's how you turn on the car. Here's the steering wheel. Here's the shift. Here's what everything is. I can teach them all that, but the only way they're going to learn how to drive is to get behind the wheel and drive the car. And that's what happens with learning anything, is the more experience they have, that's physical experience and actual hands-on, the better they're going to understand all the content that comes after. The reading and all that now makes sense because they've got a picture of what you're talking about. They understand in their mind that, oh, it's this. So I always start out activities with, I always start out a unit, a concept with something they do, whether it's to analyze data, whether it's to actually do a lab, whether it's to, it could be anything. And so the model that we use is called the learning cycle, and it had then since developed more phases. It started out with 3, and then it became 5. And it has the explore phase is where you give them an activity of some kind to do themselves, and they have to interact with it. And then they go into disequilibrium and go, what? Huh? I don't get it. Then they go, try it again, and they go back. And you help them during this phase, disequilibrium, to work through it. And then you say, okay, now discuss in a group what you think you have and work with each other and figure it out. And then they explain to you, and it helps them go, oh, I get it. You don't explain to them, they explain to you here. This is student-centered. And then after that, and they get that concept, now you can elaborate with your lecture, your readings, and go on and on, with helping them to really take that new concept and organize it in their mind, and how it relates to anything in real world, how you can do more complicated and more complex work in the elaborate phase. But you got to get them started and on the cycle. The engage is important because first they have to be interested. So almost always I start with something, that is a question, or it could be a short little video, just like I did with the Annenberg video. That was an engage, where I showed you the private universe, just to get you thinking and say, huh, that is interesting. Wow, I didn't know, that. And to get you wanting to learn and explore, to assimilate, and then disequilibrium and get a little bit of confusion, but to help you, it's good confusion, to work through it until you can go, oh, I get it, I understand. And then elaborate is where you can take it in more and more detail and more sophisticated concepts related to that concept. You always evaluate all the way through. So you're checking knowledge as they go, whether it be short quizzes, whether it be verbal, whether it be observational, whatever it is you do, you evaluate to see that they're with you in that process of learning. So advanced reasoning and thinking, now our goal is to know how do we get students in college, because to be more advanced. When you're younger learner, there's different phases of learning, and they're not age necessarily bound. It's different for everyone. And there's two phases that were before this considered their sensory motor and pre-operational, that are really fun for the young to look at sometime for the young students. But what we're dealing with in college will be some concrete and some hypothetical, deductive, or formal thinking. If they're still concrete, they really rely on the concrete objects and need to have that experience. And even if they are hypothetical deductive, the research has shown that they still work best if they have the concrete objects first, and can interact with those concrete objects or experiences first that make sense to them. When they come to us from all over, that Goutam mentioned, we don't know if they have the same common experience. So let's say I have to pick the concept of density in science. So density is a very important concept that can in every science, there's this, some aspect of density that we need to teach. So I would want to make sure that they truly understand density. So that is one I would pick to make sure they have the concrete experience, that common experience doing experiments with density. And now anything I do after that, they can do. I can move them from the concrete hands-on, where we do some density experiments and they fully understand density equals mass per unit volume. Now we can do the mathematical equations. Now I can go on to higher level thinking, because if they run into problem, I'll say, remember when we did that experiment with density where we did this and that, remember that experience? Oh yeah, okay. So you may start your whole new concept or unit with that hands-on experience. So now they have that as an anchor. I mean, in education, we call that an anchor concept. And that anchor concept, now you can connect other concepts to it. And they can always go backwards to that anchor again. You can remind them, hey, this is, that I remember doing that. Yes, we did it in class. I've got it. Okay, now this is like that. It gives you leverage to be able to go back to that concept that you dealt with in a deep way, in a hands-on way, and then attach new knowledge to it. So concrete thinkers do have difficulty with causality, cause and effect. They have trouble going backwards too. Like if you ask them to reverse, I didn't put that, but if you ask them to reverse their steps, they have difficulty with that. So these are things you can do with them to help them develop higher level. They need concrete, and they best assimilate, combinate with direct experience. Hypothetical deductive is where we want students to go. And we want them to be able to not have to use the objects, but now think about, because they've had all the experience they need and to give that foundation, and now they can think abstractly. And they can use proportions, probability, ratios, and all these other, combinatorial, controlling variables, disembedding, spatial ability. These are some of them. And these are not content bound. These are not just science. These are things we do in every discipline. Really, we use this kind of reasoning. It just may look different in that discipline. But they can reason without concrete, and they can use abstract, and more. So with the more experience they have, the more they can use abstract reasoning. I wanted to share just some of the research that I've done with this. And that is when I did a study with to see the reasoning ability level as just described, whether they're concrete or whether they're hypothetical deductive reasoners. And we studied 6th, 7th, 8th, 9th. We didn't have any 10th graders, but 11, 12, and then 13 is college. And we found a spike in 11th. You know, so you can see it gradually goes up. So the more experience they gain, the higher. But then it went down in 12th grade. And I kind of have a why here, but what, you know, what happened senior year? Do any of you have that experience of senior year in high school? Senioritis. Yeah. Senioritis. Anything else? Why at the peak in 11th grade, do you think?
College entrance exams and things like that, applying for colleges.
You bet. SAT, ACT, college entrance, taking some of the higher level courses. So their mind is there, you know, and then like someone mentioned, senioritis, students take senior release. And we also found mathematics might be not taking mathematics might be a problem if they're in STEM. But you know, this was basically how are they gonna be for STEM. But yeah, reasoning drops and then it comes back up again, which is good. And so really my goal is that, you know, this is the best thing we can do for students, is to help them develop these reasoning skills and get this spike up high again, because that's the opportunity we have when there are students and we have them with us in college. We don't know what'll happen once they leave, you know, us. We don't know if they will continue to reason at high levels, but while they're in our class, we have that opportunity, we have that moment to help them develop skills. We've already done this. Now we need to give it to them. We need to force them to think. I've worked with teachers who would say they will not give the students answers. They will keep finding ways or scaffolding for the students to come up with it themselves, because they have to practice that knowledge processing themselves and not just memorize what we tell them is to be true. We need a thinking society. And the students that in our classes, while we have them, it's an opportunity to allow them to practice those skills that they'll have forever. We also found that reasoning ability predicted, again, this was more for STEM, but it predicted whether or not they were going to stay in science if they had high reasoning ability. And then I did say with college students and the female students in that study, we did a content knowledge understanding in the beginning, and there was a difference. Males outperformed the females, but we also tested reasoning ability, and females with higher reasoning ability and abstract thinking ability overcame the deficit by the end of the course, and they performed equally well on the physics exam at the end of the course. So the reasoning ability can help students logically succeed in their courses. And so how do we advance thinking? I keep track of time. So basically, in summary, experience is the best way we can help advance, giving them as many experiences as possible. Physical and logical, mathematical. They do have to reason and solve problems. Logical, mathematical could be word problems that, and things like that you do, but practice with them first. And going from disequilibrium to equilibrium helps them. That's the aha, the accommodation where they get it. And the more we do that and process information, the better we learn, and the more advanced thinking we are able to take on. Because we practice trying to sort through and solve problems on our own. If we don't get that experience, we're used to someone telling us. And there's so many students that say, "Just tell me the answer," and they beg. And I always say, "No, don't tell them." They say, "What? I already know. What do you think?" This one teacher I mentioned earlier, he just would always turn it back to the students and say, "What do you think? Work on it together and tell me." and then they would. And I interviewed those students and videotaped them in those interviews in some of my research, and they said at first they were so frustrated because the teacher would never tell them, but they were so grateful at the end of the course because they learned so much and they learned how to think for themselves, and it really made a difference in their lives. Social transmission is another way that we can learn. We do learn from each other. That's why group learning and teamwork is very important, because we learn from one another. And anything that's socially developed, we learn from, Google. We learn from all kinds of sources. Just make sure they're good sources. And, books, and that's a form of social transmission. But definitely working in groups is very important. And then as our brain matures, we are able to take on and accept more information. However, we as teachers don't have control over that part. We have control over providing them with experiences, providing them with disequilibrium experiences to equilibrium, and allowing them to work in groups to have social transmission. Maturation is more biological maturation of the brain. Well, I mentioned scaffolding a few times. This is not necessarily only the child, it's anybody. And what we're trying to do is we're trying to scaffold students when they're in disequilibrium. Think of it like an analogy of a ladder, where we're trying to guide them. The rungs of the ladder are our questions and our clues and our modeling and things that we do to help students to learn to climb up the ladder. And here's what they can do by themselves, and here's where we want them to go. So what clues do you need to give them to help them get to the next level? Then you take that ladder out and you put a new ladder, and you try to get them to the next level, and it continues on. And some students need a lot of, if you think back on Fannie Dooley, and maybe some people needed one rung of the ladder and they were there at the potential level. Now that becomes their new actual level. Then some may need 10, some may need 3. It changes for every person as to what kind of guidance they need, and different topics it changes. And so we need to think about what are the clues that we can give them, what are the questions we can ask, what are the modeling we can do for them that will help them get there, but to get there on their own, but with guidance. And that's what scaffolding is. It's scaffolding it's like a ladder, scaffolding them through the process of learning. So to summarize this part, and then I'll show you how to do this in online a little bit. So a model for teaching that matches learning is this learning cycle model, and the 5 phases. If you think about your course and your content, and you can do it in more than just the sciences, it can be in any subject. And engage can be a news article, can be anything that would get them thinking about, oh yeah, I didn't know that's how that worked, or wow, that's an interesting story, or whatever happens that you can think of that would help them get onto the explore, disequilibrium, explain, and then elaborate can be any method that you want. Usually explore is a hands-on, or it's a dealing with data, or it's something that they do together as a group. And then disequilibrium, you're guiding them through. Then explain is always a discussion where they tell you what they found. Elaborate can be another lab activity inquiry. It could be a videos that they watch. Could be that you do a lecture. Could be they do reading. Could be all those things. This could happen in usually this takes time. You might even just do an explore, spend all one class time just doing the explore, and then then they come back next time to explain, and then next time you spend 5 days doing elaborate things, lecture, more discussion, another activity, whatever it is you want to do. So none of this happens all in one time. It can be over time and over a period of time. It can be quick, but most of the time it's over a period of time. So then, but people might ask, why would we do something like this? Why is it important? And you have to ask yourself, what's the purpose of education to begin with? Why are we here? What is our reason for teaching and being in an education system? So, and think about your discipline and what is the nature of your discipline? How can we immerse the students into really understanding that discipline versus science is not lecturing at people. If it's memorizing, I think we would, a lot of people who could be scientists probably leave, because that's not comfortable. But science is an activity, it's an action. So we need to immerse them in that action. What are we doing for students when we teach like this? How are we helping them? And we talked about that lifelong skills that they'll have forever, and every decision that they have to make, they'll have that practice of having done things for themselves. What will students need to be able to do when they graduate? Think about that when you plan your lessons. How will this help them in their future lives? And then why it's important to our society to have a thinking society. And I briefly mentioned that as well. So these are just to think about for yourself. If we have time, we can discuss. Right now, I'm going to just show you that I developed back in 2009, but I revised in 2017. Beth knows this program well. I developed a master's in science education course for teachers, and I actually got a badge. Yay! I didn't know I was going to get a badge, but they sent me a badge, and this info, intelligent.com, said it was ranked one of the best master's in science master's programs. I don't know, in whatever they do to evaluate master's program. So I was pretty happy about that. And so what I'm going to do is just show you how I've put this into a course, this model, and I'll stop sharing that one and see if I can stop sharing or start sharing my Canvas course, and it could give you an idea of how it could go into a course. Just the way it works. Okay, so here's, can you see the Canvas course right now? There's do you see? Okay, so this is actually the first course in the program, and I teach this. What I just presented, this whole course is a long version of that, only much more detail, but you just got an hour-long little version of it. And so, but what I did was I first gave them an intro and told them a little bit about how it's organized. But the modules, all of the modules in it are arranged in the 5E. So when I made the online course, this is all beginning stuff, but I have module 1, and then what is the nature of science and math? As I said, you need to first get a good handle on what your discipline is. But engage and explore. So engage, I usually do something to get them thinking. And I did a little activity there where they did some, to get them thinking about what the topic was. Then there's an explore where I gave them an activity. They did this thing called mystery boxes, and they were supposed to do this lab with their kids, with their students. Or they could I told them you can do it with anyone who's not science if you don't have a class of students right now, like, your spouse or whatever, if they're not science oriented. Then there's an explain where they come back together and we discuss and we talk about what we just discovered. And then there's elaborate where they can continue to look at PowerPoints and discussions and readings in here. And then there's an evaluate phase where they may have quizzes, or I may have other journals for them, or journal articles. So every module is designed in the 5E. I have other ones. I'll just show the earth science quick. So I developed a couple earth science courses every course in the program is designed in the 5E model. And so the modules here are the same. So like I just said, there's the beginning part, but so we started with this earth science class with an activity on the Big Bang, and they showed a video of the Big Bang. So if they can look at it, read it, and then there's questions about it to try to get them thinking about the Big Bang. And then in Explore, I have this activity called Galaxy Sort, where again these are activities because they're to teachers that they can do with their students. And so then I have this activity in the Explore where and there's the rubric and all that stuff, but they take a picture of there's different galaxies, and they have to sort them out, and they can cut them out, and because again these are for all ages students, but they can cut them out, And then they can say, well, this one and this one, M101 and M109, they're kind of similar. Okay, so put those in a pile, put the M51 in that pile, and like that. So they do this galaxy sort, and then so that's the explore. And then explain, we do discussion more. Oh, yeah, I'm in the library. Right here, I had some more media, and there's like a little video. You don't want to watch it, but that's me doing something with gravitation. I'm demonstrating with magnets, but there's a little thing there that they do. And then on elaborate, there's more reading and more discussion. They could do anything here. And then evaluate, I had them do reflection journals, but also have quizzes here. But everyone, module 2, all of them are 5E. So it can be done in online format as well. And hopefully I've also demonstrated some ways that you can have them be interactive as in this particular environment. And that's especially online, and the discussion board helps a lot, and the polls that we've used today, and having you raise your hand, and if the chat was working, which unfortunately wasn't, but next time we could also have you participate that way and post things in the chat, and then we could have a discussion on that as well. So I think that about wraps up my presentation. I wanted to be on time. I'm just a little minute over maybe. But I really would love to hear from you. I know this is putting like a whole course into 1 hour, but when we have our follow-up with the graduate students, we'd love for you to come. You're always invited, and even in the all faculty sessions, many of those are for everyone, and we'll let you know which ones are which, and you can ask more questions and access our resources, and we're here to help you be successful. So thank you for your attention. Appreciate it. Thanks.
Thanks, Dr. Cavallo.
Yes.
So if you do have any questions, yeah, Destiny.
Oh no, just saying thank you.
Okay.
Oh, thanks for being here. Appreciate it.
Any questions or comments? Again, raise your hand. The chat doesn't seem to be working, so. Going once, going twice. Okay, well, let's take a break then until our next session, which
Sounds
is
good. Thank you, everyone.
1:30 is our next session, and we will be talking about teacher-student interaction. So we'll be showing you videos with little scenarios, and then come prepared to engage and to talk and to share your experiences and to talk about what you're seeing. So we're talking about classroom management, teacher-student interaction in on-campus and online courses.
Very good. See you in a few minutes. Thanks.